This is part 2 of the Jacob's Algebra, Chapter 9, Lesson 1. I had started working on number 8 and the time ran out, so I got cut off. So we're going to start over with number 8. Number 8 is just like number 15 that I assigned for homework. We have two monomials, 5x cubed and 20x cubed, and we're going to add them and we're going to multiply them and see what happens. So part A says, what is the coefficient of the monomial that results from adding these two? So if we have 5x cubed and we add 20x cubed, what is the result? Well, first we have to see, is the degree of our variable the same in both cases? We have x cubed and we have x cubed. They're both third degree. That means that we can write down our x cubed. Now, what number goes in front of it? What is our coefficient? We need to add our coefficients. 5 plus 20 makes 25. We can only do this because both of our x's were to the same degree. If they're different degrees, we cannot add them. So for part A, it says, what is the coefficient of the monomial? The coefficient is the number in front of the x, so our coefficient is 25. Part B says, what is the coefficient of the monomial that results from multiplying them? So that's taking 5x cubed and multiplying it by 20x cubed. Now, when we're multiplying two numbers with powers, what we need to do first is multiply our coefficients. So 5 times 20 is 100. And then we write down our x, and for the x, we add our exponents. So we have 3 and we have 3. When we add those together, we have 6, 100x to the 6th. The question was, what is the coefficient? The coefficient is the number in front of our x, so that is 100. Okay, part C wants to know, what is the degree of the monomial that we get when we add them? Well, we added them up here in part A, and the degree is the power on the x. So that's going to be 3. For part D, we want to know, what is the degree of the monomial that results from multiplying these? Well, we did that over here in part B, and the degree is the exponent on the x, so that's going to be 6. So this was number 8, which is just like number 15 in the homework. Okay, moving on to number 9. Number 9 is just like number 16 in the homework. And it says, if possible, write each of the following expressions as a monomial. It's always possible to write it when you have monomials that you are multiplying. It is not always possible when you are adding monomials, because you can only add monomials that have the same degree for your x. So we're going to do part A first, and we have 13x squared plus 2x squared. Well, both of these have x squared, so that means that we can add them. So when we're adding, what we want to do is write down our x with its power. That's why everything has to be to the same power. That has to all have the same degree. And then we add our coefficients. What is 13 plus 2? That's 15. So if we had 13x squareds and then we got 2 more x squareds, then we would have 15x squareds. Okay, part B, we have 13x squared times 2x squared. Now we can always multiply. When we're multiplying, we're going to take the coefficient of one and multiply it by the coefficient of the other. So 13 times 2 is 26. That is our new coefficient. And then we're going to write down our x, and the power on the x is going to be the sum of our degrees. So we're going to take 2 and 2, add those together to get 4. So we have 26x to the 4th. Okay, part C, we have 13x squared plus 2x. This one is not possible. We write no, we cannot write this as a monomial. And that is because this x is to the second power, but the other x is to the first power. When it's not written, it's understood to be 1. We cannot add them unless they are both the same degree. These are not, so we cannot add them together. Okay, part D, 13x squared times 2x. Now we can always multiply, so that's not a problem. When we're multiplying, we take the coefficient of one and multiply it by the coefficient of the other. 13 times 2 is 26. Then we write down our x. The power on the x, the degree of the x, is going to be the sum of our exponents. We have 2, and there's no exponent written here, so it is understood to be 1. 2 plus 1 is 3, so we have 26x cubed. Now we're going to jump down to part I. That's supposed to be an I there. And what we have is 4x to the 4th plus 4x to the 4th plus 4x to the 4th. Okay, notice that we have x to the 4th for all of these. That means all of these are 4th power. They're all 4th degree. So we can add them. So we'll go ahead and write down our x to the 4th. Now what we need to do is add our coefficients. We have 4 plus 4 plus 4. That's 12. So we have 12x to the 4th. Now let's look at part J. Part J has 4x to the 4th times 4x to the 4th times 4x to the 4th. We can always do multiplying. When we're multiplying, the first thing we do is we multiply all our coefficients. 4 times 4 is 16, times 4 again is going to be 64. Then we write down our x, and the power on the x is going to be the sum of all of our exponents. So we have x to the 4th and x to the 4th and x to the 4th. 4 plus 4 plus 4 is 12. So we get 64x to the 12th. Okay, looking at part K, we have 5 times 2x to the 10th. This time we can always multiply. So what we do is we take our coefficients and multiply them together. Well, you can see that 2 is the coefficient for 2x to the 10th. What is the coefficient for 5? Well, this can be written as 5x to the 0 because x to the 0 is 1. So our coefficient is 5. 5 times 2 is 10. Then we write down our x, and the power on the x is going to be the sum of our exponents. That's 0 plus 10. So that's 10x to the 10th. Okay, the last one for number 9 is part L, which is 2x to the 10th raised to the 5th power. Now, anytime you're raising things that are in parentheses to a power, everything in the parentheses must be raised to that power. So we're going to raise 2 to the 5th power, and we're going to multiply that by x to the 10th, which is raised to the 5th power. Well, 2 to the 5th power is 32. X to the 10th raised to the 5th power. When you raise a power to a power, you have to multiply the exponents. So this is going to be 32x to the 50th. Okay, so that was number 9, which is just like number 16 in your homework. Now we're going to move on to the last one, number 10. This is just like number 17 in the homework. For number 10, you need to find the perimeter and the area of each rectangle. So for part A, you are shown a rectangle that looks like this. And this side is 3x, and this side is 5x. Well, you know because it's a rectangle that the opposite sides are the same length. So this side has to be 3x, and the bottom side has to be 5x. Okay, so first let's find the perimeter. The perimeter is the sum of the length of all the sides going around. So we have 3x plus 5x plus 3x plus 5x. That's just going around. So we have 3. All of these are x's. So our x's can all be added to each other. So we can just write that down here, s and x. Since they're all the same power, now we just add our coefficients. 3 plus 5 is 8. Plus 3 more is 11. Plus 5 more is 16. So 16x is the perimeter. Now we need to find the area. The area of a rectangle is the length of one side multiplied by the length of the other side. So the area is going to be 3x times 5x. So when we're multiplying these two numbers, first we multiply our coefficients. 3 times 5 is 15. Then we write down our x. The power on the x is going to be the sum of our exponents. Both of these have an understood 1. 1 plus 1 is 2. So it is 15x squared. Okay, I'm going to get a new page. So for 10C, we have a rectangle that looks like this. The top side is x, the left side is 6x squared. We need to find the perimeter and the area. Okay, this time I'm going to show the perimeter a little differently. We know that the perimeter is the lengths of all the sides added together. Well, if this side is x, then the opposite side must be x. So we have 2x. If this side is 6x squared, then this other side must be 6x squared. So we have 2 times 6x squared. Now we can't add our x to our 6x squared, but we can still simplify this. Our perimeter is 2x plus 12x squared. And that's as far as we can take the perimeter because we can't add our x term to our x squared term because we don't know what x is. Okay, so now let's get our area. Remember, the area is length times width. So our length is 6x squared and our width is x. We multiply our coefficients, which are 6 and an understood 1, so that's 6. Then we write down our x, and the power on the x is going to be the sum of our exponents. So we have 2, and then we have an understood 1. 2 plus 1 is 3, so it is 6x cubed. And that is how you do number 10, which is just like number 17 in the homework.